Hello everyone and welcome to Detecting Threats with the Splunk Threat Research team using the attack range. What does the Splunk Threat Research team, or STRT, specifically do? Well, the team develops security content for Splunk products. Now, let's dig into what this means in a little bit more detail. Specifically, we study threats. And studying threats really mean monitoring threat feeds, watching security advisories, looking at things that are happening on the wild, and simulating these threats. And to simulate these threats, we use the Splunk attack range, we build the lab, and we launch attacks against it. And out of that comes attack data sets. And so that's the next big thing our team does is create data sets. We look at, out of these data sets, we look at simulating either real systems on your network, or we simulate these attacks using a project called the Tom Red Team, which is also open source. Ultimately, we store and catalog all these attack data sets under the Splunk attack data repository. With these data sets in hand, our team then is able to build Splunk analytics, or as we call them, detections. And again, how we go about this is we ingest all this data into Splunk, and of course, we're then able to write these analytics on Splunk itself. And we focus on adversary tools, tactics, or procedures to detect these attacks or these threats whenever possible. And the final piece of us building this detection is making sure that we carefully tune each detection or analytic to reduce the amount of false positives and make sure it catches the expected behavior across all of our customers' environment. Out of all this work, we tend to write our own tools, and in the hopes of being more transparent and sharing with our community, we release them to the community. These tools include not only our detections themselves and the release process and applications for those detections, but also the CI/CD pipelines that we built to test them and make sure that they're honestly working as they go out the door. And I mentioned we share with the community. And our team, again, our focus is to build a community around these detections that we provide so we can all better defend ourselves. And we do this by sharing our knowledges across various, you'll see us presenting in various security conferences, sharing our knowledge. Also, in hopes of increasing our transparency, we do a lot of our development under our open source repositories in Splunk. And as well as we take community feedback and build additional features given community feedback using these community resources. Now let's talk a little bit about the Splunk attack range. I mentioned earlier, Splunk attack range is actually an open source project. It's actually the most starred open source project today under Splunk in GitHub. You can grab the code for free right now at github.com/splunk/attack range. Splunk attack range has three major goals in mind. The first one is to build a lab infrastructure that's replicable and scales. The second is to simulate attacks, and specifically, we support two simulation engines out of the box, a Tom Red Team and PurpleShark. And the third is using the generated logs from these attacks, be able to test detections and or also write detections against these generated logs. Let's dig a little bit more into the Splunk attack range architecture. In more details, on the left we have the different functions the Splunk attack range command line interface supports. They are building a range, build, simulating an attack, simulate, testing a detection, test, dumping the raw data index by an attack range, dump, and replaying a raw data set into the attack range, replay. The attack range uses two underlying technologies to accomplish its goal. One is Terraform to build the host and environment configured, and the other one is Ansible to configure and tie together the whole system. Finally, when building a range, we support AWS and or Azure clouds to host environments. This not only allows us to build a massive infrastructure and scale it horizontally to mimic real-world enterprises, since the attack range operates on its own VPC, it allows us to not only create all of this in its own standalone piece of your cloud account, but also easily tear it down without affecting anything else you have running in your cloud account. The attack range supports a varied set of assets like Windows Domain Controller, Active Directory, and Linux servers, and even C2 operations via the Kali Linux instance. Set up to collect logs into a Splunk server also builds that has pre-installed all the TAs necessary and plugins to be able to bring all that data back in a normalized fashion. Finally, and optionally, the attack range can bring up a Splunk SOAR instance pre-configured to allow analysts to also test their investigative and response capabilities. If you don't want to go through the trouble of building an environment, launching attacks, and dumping the data, and you just want to see attack data right away, we've cataloged all these attacks that we launched against the attack range under the Splunk attack data repository in Splunk. Another free tool, again, that allows you to easily replay attacks into a Splunk server. You can see what real attacks look like with your logs. With all that said, let's jump right into a demo. I'm going to show you how we can launch an attack using the attack range and then actually detect it using Splunk's enterprise security content updates. All right, we're going to start off by going to the research.splunk.com website. In here, we can dig into the analytics story, which are the different use cases that the threat research team for Splunk ships. Specifically for today's demo, let's look at credential dumping attacks. Credential dumping attacks are basically attacks that an attacker will launch against an operating system to obtain their credentials and move laterally to another host, for example. And for the purposes of this demo, let's dig into specifically the credential dumping through comms services. Here you go. So dump LSAS, specifically LSAS memory via comms services.dol. Now, this detection is pretty straightforward. It's using here, you can see the endpoint processes data model. And it leverages the endpoint data model, and specifically, in our case, it was tested with Sysmon. It works on Splunk Enterprise and Enterprise Security, as well as Splunk Enterprise Cloud. I want to make a quick note that this specific detection is mapped to two MITRE techniques, a parent technique for OS credential dumping, which is T1003, and the sub-technique T1003.001 is specifically OS credential dumping through LSAS memory. We're going to be using that in just a minute. Here we are in our attack range already built using Docker, and I'm just going to go ahead and run attack range show to show you exactly what environment we have built. So we have essentially a Splunk server and a Windows domain controller in our environment. Both are running, and here are different credentials for each of these if you wanted to jump into the domain controller and or the Splunk server via SSH Azure Web. We'll be doing that in just a minute, but first let's simulate this LSAS memory dump through comms services.dol. And to do this, we'll run the simulation command in attack range. So Python attack range py simulate, and if you recall from earlier, simulate needs two specific arguments that it takes, and just to kick things off. One is the simulation technique. In our case, for LSAS credential dumping comms services.dol, if you didn't catch it on the website, is T1003.001. And our target is the next argument attack range needs, and in this case our target would be the Windows domain controller here. Just pass it along, and again this kicks off the process to load up, in our case, since we didn't change the simulation engine, Atomic Red Team, and run Atomic Red Team using this specific atomic or technique against that environment. Here we get a list of all the successful tests. Again, we absolutely see that one of them is using LSAP using actually not mini dump, it was a comserve.dol here. So here, let's run show again. And we can see our Splunk server IP is this, so I'm going to go ahead and flip back to the browser so we can find this attack using our Splunk server. Here we are, our Splunk server. I just logged in using the credentials given in the shell command. And if you go under search, we should be able to just copy and paste our search syntax right from the Splunk research site. And again, this search catches comserve.dol being ran, so we should be able to see that here in a second if this attack did work indeed. And I'm going to just run this across the last 24 hours. Absolutely. Looks like our attack did work indeed. The user administrator using process run DO32 tried running the mini dump function and saving it to like a temporary dump folder using com service the DO, which this has credentials in it. This is not good. So a SOC would then schedule this next as an alert. I'm going to share very quickly how a SOC analyst can actually enable this to cache this threat whenever it hits any other system. We quickly use enterprise security for this. So we go into our go into configure, content, the use case library. We're going to find the, again, our credential dumping analytic story here. Find the right detection. This is our search. Again, you confirm it quickly works by running it the last 24 hours. Perfect, same results. If you click here on edit correlation, a SOC engineer can easily configure not only the search parameter, filter out any actual false positives you might have seen in the previous screen, but also add, remove, or clear out annotations. Again, this already has a preset scheduler for us every hour for an hour back, and it also has a notable event already pre-configured out of the box to shoot over notable or an alert if it does find this, with a specific extraction for the entities, as well as it has a pre-configured risk score for this event, specifically across the parent process and the process name that triggered it. And the risk score modifiers are specifically targeting the user and the destination that this event was seen in. This concludes our demo. Now that you've seen the demo where we took a built attack range, we launched credential dumping against it, and then we were able to detect that attack using out-of-the-box detections from Splunk Enterprise Security Content Updates, I want to give you some key takeaways. One key takeaway is you can use the attack range to test and develop detections for yourself. Two is, if you don't have a team, or honestly don't have the cycles to be developing detections on your own, our team is already putting out free detections for the community under research.splunk.com. We have over 700 free detections and playbooks for Splunk. If you have any questions, feedback, anything at all, we love hearing from you all. Please join the conversation with our threat research team under our user Slack. And finally, here are the 3 free tools we presented on today. Splunk Security Content has all of our detections in it. Splunk Attack Range has all the attack range code and steps to get you started. And Splunk Attack Data has all of our catalog data sets, as well as tool to replay that into your own Splunk server. If you're sticking around Conf, there's a whole lot of attack range fun happening. I highly recommend you to check out these 3 talks from different team members that are covering different aspects and different ways to use attack range in your own environment, basically. Thank you very much, and I hope you have a great day.